a singleton class so that we get to understand how it works. Here's what we're going to do. I'm going to create a class called scoreboard. This particular class called scoreboard is going to have, let's say, scores of different players. And the idea is that there should be only one object of it. As simple as it sounds, there should only be one object of it. And here's what we're doing. We want to plan it in such a way that no matter how many times we create it, we get to access the same scoreboard. We get to access the same thing. I'll just take a simple example out of this. Let's start with this. Let's say we're going to create, okay, let me create it empty to begin with. Let's say we're going to create two objects out of it. The two objects we're going to create out of it are going to be, let's say, player 1 and player 2. Once this is done, let's take player 1. Oh, let's create some functions. We don't have any functions, right? So let's create a function called add score. And let's create another function called get score. I think this should be enough. Two simple functions. Now, add score is where we add a score. Let's take the object and a score. So we're just going to use self.score for that particular object plus equals score. Similarly, to get score, we'll just use return self.score. That's pretty much it. Let's try this out. Now, if I create two objects, okay, again, let's read some. If I create two objects, if I had p1.add score of 25 and p2.add score of 50, and if I print p1.get score, and again I print p2.get score, here's what I'm going to get as the output. Okay, I'm so sorry, I'm still sending the Gmail part. It should be, and let me rename this. It's going to be both3. Again, the best way to work around this is always a database example so that no matter who accesses, they get the same database connection to perform any operation. That's one of the best ways to understand this. So once you run this, okay, let's see. Oh yeah, we don't have any self.score, right? Let's make self.score is 0 initially. And remember, you can't have self.score specified outside anywhere. You either have to specify it as score equals 0, or you have to make it within, let's say, an initializer or init function. So we have a variable called score for this class, which is 0. By default, any object that is created will have this variable. And whenever we create add score, whenever we add score, it adds to that. Whenever we get score, we'll get to that. Now remember, all players who are playing the game will add score to their own score. It's not a common scoring variable. It's not a single object where all of them will add to the same score. Now think about this. Let's say you're playing a game, which is a two-player game or a multiplayer game, where you and few of your colleagues are playing together, and whether you score a hit or somebody else scores a hit, it adds to the team score. And let's assume only one team can play at a time within the game. Now, in this multiplayer game, let's say whether Eric scores or James scores or whoever else it is that scores, the score will be added to the team score. And there can only be one such value. So we're just going to use a class like this to create it. Again, the reason why I'm not starting with the database connection class here is because we haven't learned how to connect to the database yet. That's why I'm just starting with this. Ahead in time, you can, of course, utilize the exact same logic to make sure that your database has a singleton class. And it's something a lot of people don't do. And a lot of people create their own objects, and a lot of connections get created to databases. And I've seen it overwhelm databases in a lot of real world applications because people just don't know good design patterns. So there are these websites which will help you a lot to become really good developers. So uh, please look into them. They really help you out a lot. Anyway, let's start with one thing at a time. Now, how do I make this a singleton class? That's the next step. That's the thing that we want to do. Right, let's start with it. We're going to create a variable, an internal variable called underscore instance, which will be none, initially indicating that no objects are created. This is our initial assumption. Now, one more thing that you need to know, any variable written with underscore inside a class is a private variable. It's not going to be accessed from the object. For example, if I print p1 dot underscore instance, take a look at this. Okay, I'm so sorry. It should be double underscore. My mistake. There you go. Not a single underscore. You can see when it's a single underscore, it's still colored brighter. When I make it double underscore, it becomes grayed out. That means it's not accessible outside with an object. So you get to see scoreboard has no attribute called double underscore instance, but it does have it. It has it. It's just that it's accessible only within the class. You cannot access it outside the class at all. That is the difference here that we need to know. Right. Anyway, let's just make it back to underscore instance, just so we understand. All of these are some simple things we get to see, right? Now, we know that we have a function called double underscore init double underscore that executes the moment an object is created. We know this. However, we have an additional kind of function that can execute when, especially when you perform some further operations. We have function like double underscore new double underscore. This is a particular function that gets executed. The difference is this is called before init when an object is created. It is used to control the creation of object itself. So the idea is double underscore init double underscore executes when an object is created. But if you want to do something before that object is created to check condition like should I create this object or not, if you want to check conditions like that, you can use this function. So this function executed before an object is created to control object creation logic. That's what it is. So let's start with this. And one more thing, you need to specify the current class within it. I forgot about it. CLS is the class. The class, if you see here, it is scoreboard. CLS is the short form to access the current class. So please note that. Please remember that. So what we need to do is anytime a new object is being created, this will be called first. When this is called first, we're going to run the following operation. We're going to check if class dot instance, this is a variable of this class. If this particular variable of scoreboard class is none or not, if it is none, that means no object is created yet. That is exactly what it means. If it's none, we don't have any object created here. And that is when we're going to create an object. If it is not none, we are not going to create an object. That is all that we need to do. That's the whole idea. So if it is none, we're going to create an object. And how do we create an object? Simple. Let's start with this. Again, these are not our basic logic. These are not something most people will ever learn when they start, let's say, programming or Python programming because I'll just be honest about this. It's not something many Python developers as tutors themselves might know, or it's most of the times not something many developers will often teach as a part of the basic thing because they expect to teach only basics and would not think of how that participant in the session would need to go ahead and make a bigger career or so on and so on and so on. So these are some things I just often add to our sessions for these purposes. So yeah, you'll see a lot of differences with regular sessions. So please note that and please bear with that. Right. Let's go on with where we were and continue from there. Now, back to our current example. Here, we have if class instance is none, only under that condition, here's what we're going to do. We're going to create class instance. Remember, we have no object yet, and that's why we're going to create an object. That object that we're going to create here is going to be created with some specific line of code. Now, this is only for us to understand singleton class, so it's all right if you don't get to know this entire line right now. Over time, when you start working on design patterns, this will make more sense. So please don't worry about it. I'm just going to write this line of code and explain it in short to avoid too much confusion. That's it. So this is going to create an object that is, if no object exists, it's going to create an object. Again, there are other ways to do this. There are 10, 20 ways to do the same process, but this is the process I'm choosing. Again, all you need to know here is it's going to create an object. Let's not worry too much about it for now. Once it is done, I'll just write instance, whatever the instance that we have created. Instance is no longer none because in this instant, I have created an object. And that object score will be set to 0, which means I can skip this. So whenever we want to access this particular object, here's what you need to do. You can just remember it is cls._instance. So here's the scenario. Whether one object gets created, two objects gets created, 10 objects gets created, doesn't matter. Each time an object is created, it's going to go to _new_. It's going to see if there is no object created. If there is no object created, it's going to create one. What if there is already an object created? In that case, we're just going to return the object created. This is all we're going to do. I'm just going to point this out in short. For scoreboard class, when P1 is about to create an object, in scoreboard underscore instance is none. So since it is none, scoreboard is going to create an object and it's going to return that object. Next, when P2 wants to create an object in scoreboard, it sees underscore instance is not none. It has some data. So that data itself is returned. So P1 and P2 will both point to the same object. That's how it works. Now let's see whether our logic works as expected or not. If you run this, okay, let me skip this. If you run this, you get to see we are adding 25, then we are adding 50. Both are added to the same object. Hence, we get 75 and 75. This is better suited for, let's say, database creation and so on, which helps us understand this, let's say, in a much, much better way over time, just for our understanding to begin with. Anyway, with this known, with this understood and observed, let's go ahead to the next part. Now, if there's any queries so far, just on the basic idea of object creation or object-oriented programming basics, or let's say the idea of what we're doing so far in terms of design patterns, please let me know. If there are no queries, we'll move ahead right away. Also, I just want to ask one query. I hope this is fine for everybody to walk through with respect to the logic, concept, and pace. I know that design pattern is not something anybody is expected to learn in their first session, but knowing solid principles and knowing at least one design pattern is going to help you a long way in future. Even if you just know what are the design patterns, you can just learn and implement any one of them to work around. So please let me know with a thumbs up if if you felt this was worthy of the time spent on it, because it's not something that we generally get to. If you felt we don't need to go through additional concepts similar to this, you can let me know that with just one text in the chat window as well, so I can stick to the way you want the concepts and I can work around them. That should never be a problem. So all right, so right, no specific responses, so we can move ahead in that case. Right, so let's go ahead now. Moving on from here, now that we just got to know how to work around basic concepts of classes and objects and how we can store some data within it, like with the mail class, how to send mails, and even perform some basic operations like we did right now. Let's go ahead to the next step. Let's go ahead to the next operation where we start to learn further things. Again, please note one thing. The way we have worked around object-oriented programming is quite limited, not in depth, purely because one of the requirements pointed out to me was that let the concept of classes and objects be limited, and let's focus more on other aspects of Python, other aspects of Python and development. That's the reason why we have it slightly limited in our case. So yeah, with this, let's go ahead and yeah, start to work around the next things right away without too much delay. Right. So moving on to this, um, just a quick question before we go ahead. Would you like us to walk through the following things with a couple of quick examples? That is inheritance and polymorphism, so that you can implement them ahead. If you'd like us to walk through these two uh, concepts with two very quick examples, please let me know. We can take very quick examples of this and work around it. If not, we'll just move ahead from this. Um, Also, these are some things we often end up using, which is why I wanted to clarify this. So yeah, any response would be very helpful for you to let me know, guys. Um, so any responses, just please let me know if you would like us to go through this or not. That should be fairly simple and straightforward enough for me to make sure that we go ahead with this or not appropriately.
Just speaking from experience, because I know what they are, I don't know that how useful they would be for projects that we might do here. But I already know about them, so I'm not sure what other people think.
All right. If I'm right, you just want to know the application of it. So one small application of it to understand the purpose of it, because we are aware of what it is, but not where to use it. Am I right in assuming that?
Sure. Yeah, if you can provide examples of what we might use them in
Perfect.
for projects like this, that'd be great.
Perfect. That sounds perfect. All right. Say let's do that um, with this. All right. So let's go ahead. Let's start with inheritance. Now, again, I'm not going to go too much in theory of it. I'll maybe take just a minute to recap it, just in case those who don't know it are aware of it. Let's say there's a class called mail. We just saw this. It has some functions. Let's say there's a class called mail reader that we saw. Mail reader just inherited mail class in it so that it has all the functionality of this class so that you can use here. Now, the idea of inheritance is in Python, we call it as is a relationship. The reason why we call it as is a relationship is because the whole subclass or derived class, whatever you create, is gonna be an instance, is an instance of the base class. Now, a real world example of generally where we might end up using it is take a look at Amazon. Now, whenever you go to Amazon website, you can sort through different electronic products, right? You can sort through laptop, let's say desktop, and things like um, earphones or whatever it could be. It could be whatever products that it could be. So some of these products will be under some category that you see, and some of these categories, some of these products will be some under some different categories. The way they use it, the way they make sure that you can sort and filter in any way, whatever you want in Amazon is through inheritance. I'll give you a simple example. Let's say in Amazon, when you go for storage devices, in storage device, you will have different kind of storage devices, hard drives, solid state drives, pen drives, and so on. Now, all of these will have a common class called storage. The idea of storage class is to have, okay, first let's start with the basic of what Amazon does. I don't want to go in depth directly to this. So the basic idea here is Amazon will have a class to begin with, let's say, called product. The idea is each product is going to have certain variables to it. Each product is going to have certain variables to it, like let's say name, price, and description, all of these things, and some images if they're attached to it, and so many of these things. Now, these are what we have in a class called product. There will never be an object of this class. Instead, the next thing that we'll have is a class called storage. Storage will inherit product. When storage inherits product, storage will automatically have all these things. So every different kind of product that Amazon will have, it will by default have all these criteria, which are the basic criteria for any product. So storage will also have name, price, description, images. On top of it, to sort and filter in storage, you will have size or capacity, read speed, something like, let's say, read speed and write speed. You don't need this for all products, right? You need this particularly for storage products. Within this, again, you will have another class called, let's say, HDD hard drives, and you will have specific filters, specific variables that can help you filter hard drives. Hard drives will have rotations per minute. If it is pen drives, it might have something else like type, like it could be type C, type A, type B, or USB 2.1, whatever it could be. So there are a lot of these different parameters that will come up, and all of these are going to inherit storage, so they don't have to take these variables ahead again or these variables again. So this is one example of where inheritance is actually used in reality over there. But we're just taking a small example to just inherit mail to mail reader. But you can see just by a simple scenario of where it's actually used elsewhere. However, for polymorphism, on the other hand, we need to take a very different example to just understand. So I'm just going to take one small example to take a look at it so we can observe and understand how polymorphism works out. And we're going to do this fairly quickly. And followed by this, we're going to move ahead to the next part of object-oriented programming. Now, in our case, whenever we start to work on these. Oh, and one more thing that I did not point out when we just took a look at this. In mail, we just inherited mail to mail reader. In Amazon example, you inherit, let's say, product to storage all the way over to, let's say, hard drive, HDD. Now, this is where storage is inheriting product, HDD is inheriting storage, and this is essentially called a multi-level inheritance because there's one level here and another level here. So it's a multi-level inheritance, just some terminology that we need to know if you're ever going to remember that or look into it ahead in time or need that ahead in time. Another way to do is multiple inheritance, where you have something called product, which is abstract, and storage, which is abstract. So any product that is a storage related product, it's going to inherit these two together. So any product, let's say it could be a hard drive. So a hard drive class will inherit product, comma, storage, both together, which means it's going to have all the parameters of product and all the parameters and functionalities of storage both. And then additional things can be added within it. So there are both ways we can work around. There are these two ways we can work around it. This will inherit both of these in this order. That's essentially how it works.
I have a question.
Yes, please.
So, um, how do I phrase this? Should there be unique fields in product and storage? Like you can't have the same name for one field that's in product
Okay.
that's in storage.
I completely get this point. I totally get this point. And this is what's going to be my next point. This is exactly going to be my next point that I'm going to observe or focus on. So thanks for letting me know that. And I'm glad we got this question. The point that you made is the exact reason Java as a programming language does not allow multiple inheritance. So when Java programming language was developed, they realized, hey, we should never allow multiple inheritance to happen because what if product has the same variable name and storage has the same variable name, and when it is inherited, which one does hard drive class read? Or if product has the same function name called description and storage has the same function name called description, which one would it inherit? And that will lead to what Java specified as ambiguity, which is why your program would never compile, your program would never be in a position to run. Instead, what Python does, on the other hand, is if you have a variable, let's say name, and by some reason there's another variable called name here as well. Since you're using hard drive, by default, which is the first class that you're inheriting? That is the class from which your variable is going to be taken. For example, if there is going to be a function called description here and another function called description here, it's always going to take description of the first class you're going to inherit. So whenever you call description, it's going to access this. This is how it works in Python when we talk about it. Right. I hope that makes sense.
Makes sense. Makes sense.
Right. All right. So yeah, let's move ahead from it. Also, if you'd like me to go through a few examples of inheritance with this, please let me know. But in the interest of time for now, I'm just mainly focusing on the main part of object-oriented programming and the most important part of it so that we get to look at it, observe it, understand it, and focus on other things within this as well. Right. Now, Now, let's move on to the next part of this. Let's move on to the next case within this, right? Now that we have this, yeah, let's go on to polymorphism. I was just wondering where was I heading to up next, right? So the whole idea of polymorphism is to use specific tasks, very specific tasks, and I'll show you how. If I write 3 plus 3, Python is going to give me 6. If I write A plus B, Python is going to give me AB. So Python identifies, depending on which class these variables belong to, and it'll perform a different operation for it. This is exactly what we call here. This is, in short, what we call a simple polymorphic application. Polymorphism is where you have one entity, which is a plus symbol, but it works in two different ways. That's it. So you have one single entity that works in multiple ways. This is what we call as polymorphism. Now, let's take a look at it, and let's take a look at how exactly it works and how exactly this operation is performed. Now, let's start with this. If you have your own class where you want to perform plus, for example, or you want to perform some minus or multiplication or division, you want to perform some overloading of an operator